Well, welcome to 9.3 notes. We're talking about arcs and chords. We've already discussed the definition of a chord, but just to recall, a chord is a segment with endpoints on a circle. If a chord is not a diameter, remember a diameter is the longest chord, so if a chord is not a diameter, then its endpoints divide the circle into a major and minor arc. So our first theorem that we're going to take a look at is theorem 9.2. It says in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So in this picture, if I knew that segment FG is congruent to segment JH, if I knew that, then that means that the measure of the arcs will also be congruent. So that means that the arc FG will be congruent to arc JH. So example number 1, it says circle W has congruent chords RS and TV. If the measure of arc RS is 85, what is the measure of arc TV? So if I know that that arc right here is 85 degrees, according to theorem 9.2, because my chords are congruent, that means that arc TV right here is also 85 degrees. It's that simple. We're done. Look at example number 2. You're thinking, well, how could it get a little bit more difficult? All right, it says in the figure, circle A is congruent to circle B, and the measure of the arc, WX, is congruent to the measure of the arc, YZ. I need to find the length of WX, or chord WX. Well, because these arcs are congruent, that means that YZ will equal WX. So, YZ is 5x plus 6. Just do a little substitution. That equals 7x minus 2. I'm going to go on and add 2 to both sides. So I get 5x plus 8 equals 7x. Subtract the 5x from both sides now. I get 8 equals 2x. I divide both sides by 2. And we get that x is 4. But I'm not finished because I want to know what is the length of WX. So all I have to do now is plug in a 4 wherever I see an x. So 7 times 4 minus 2, 28 minus 2 is 26 units, whatever those units are. So WX is 26. If I scroll down here to example number 3, it's going to be very similar to what we just did. I have congruent congruent arcs, so therefore my chords will be congruent. So that means LM equals RT. LM is 2x plus 1. RT is 3x minus 5. And we could just go on and solve this. I'm going to, in one step now, I'm going to add 5 and subtract 2x from both sides, minus the 2x and add the 5. So I get that 6 is equal to x. I think you guys could solve that equation. And now in order to find the length of LM, I'm going to plug in the 6 wherever I see an x. So 2 times 6 plus 1. So that means LM is 12 plus 1, which is 13. Okay, going to page 2 of our notes. We're going to take a look at 2 more theorems here. It says if a diameter or radius of a circle is perpendicular to a chord, then it bisects the chord and its arc. So if diameter AB is perpendicular to chord XY, then I know that XZ and YZ are congruent. And since they are congruent, I know that arc XB is congruent to arc BY. Again, that diameter is perpendicular and it cuts that chord in half. So we would say it's the perpendicular bisector. And that's what theorem 9.4 is. The perpendicular bisector of a chord is a diameter or radius of the circle. So if I know that AB is a perpendicular bisector of chord XY, then I know that AB is the diameter of circle C. That's the only way that that would happen. So let's take a look at two examples here. Example number 4 in circle G. The measure of arc DEF is 150 degrees. And they want me to find the measure of arc DE. Well, I see that EG is the radius. So highlight right here. I know that EG right here is the radius of circle G. I also know that it is perpendicular. So since it's perpendicular, I know that this guy is going to be the perpendicular bisector. So that means right here that HF is also 5. And going to go back to theorem 9.3, since it's perpendicular, I know that this arc DE is going to be congruent to arc EF. And since it's 150, it's going to be bisected, so I'm going to take 150 and divide it by 2, which I get is 75 degrees for each one of these arcs. So that means that the measure of arc DE is equal to 75 degrees. Example number 5 is a tricky Ricky. I don't want you guys to take this for granted here. There's a few things, and one of them is that you need to draw in a radius. It says in the circle below, the diameter QS is 14 inches long, and chord RT is 10 inches long. They want me to find the length of segment VU. All right, so if I know that RT is 10 inches long, I know that QS is the diameter. So that means that the distance from R to U is 5, and the distance from U to T is 5. Also, the diameter is 14 inches long. So the diameter is 14 inches long. That means I could draw in a radius, and I'm going to draw in a radius from V to R, and that means that VR is 7. And remember, the diameter is equal to 14. So that means the radius is 1/2 of 14. That's how I got the 7. So that means VR is 7. So now I've got a simple Pythagorean theorem problem. I need to find the length of VU, which I'm going to call X. So 5 squared is a leg. So 5 is a leg. X is a leg. That equals 7 squared, which is my hypotenuse in that right triangle. So 25 plus x squared is equal to 49. I get x squared is equal to, and that's when I subtract the 25 from both sides, so 49 minus 25 is 24. So that means x is equal to the square root of 24. Remember, we have to take the square root here. So square root of 24, I could evaluate that on my calculator and round that bad boy to the nearest tenth. And just for our sake, so the square root of 24 is 4.89. So x is about 4.9 units if I round to the nearest tenth. If you are a stickler and you want to make sure that you know how to write this as an exact answer, remember the square root of 24 is equal to the square root of 4 times the square root of 6. And the square root of 4 is 2, so I got 2 square roots of 6. That would be an exact answer if you wanted, or x is about 4.9 units to the nearest tenth. Okay, page 3 of our notes. It says, in the same circle, or in congruent circles, 2 chords are congruent if and only if they are equidistant from the center. So another congruency, we know already that if I have congruent arcs, then I have congruent chords. Now I'm stating that if I know the distance from L to X and L to Y, if they are the same distance away from the center, then that means that FG is congruent to JH. So in circle P, I know that EF equals GH. I need to find the length of PQ. So what do I have? I have congruent chords. So if I know that my chords are congruent, then they have to be equidistant from the center. So it implies they are equidistant from center. So that means that PQ right here is congruent to PR. So that means PQ is equal to PR. So 4x minus 3 equals 2x plus 3. I'm going to go on and solve this in one step. I think you guys could handle this math. I'm going to subtract the 2x from both sides. I'm going to add 3 to both sides. That gives me 2x equals 6. When I divide both sides by 2, I get that x equals 3. And now in order to find the length of PQ, I'm just going to plug in the value of x. So that's 4 times 3 minus 3. That's 12 minus 3, which means PQ is 9. So Pikachu is 9. Finally, very similar to what we had here in circle R, I know that MN is equal to PO, which equals 29. So if they're equal, again, I have congruent chords, which means they are equidistant from the center. So that means RQ will equal RS. So RQ is 3x minus 6. RS is x plus 8. I'm going to solve this in one step, basically. I'm going to subtract the x from both sides. I'm going to add the 6 to both sides. So we get 2x is equal to 14. We divide both sides by 2, and we get that x is 7. So now if I know that x is 7, that means RS is equal to 7 plus 8, which is 15 units, whatever that may be. That's the end of the notes. Please check Schoology for the homework. I hope you guys have a great day, and I'll talk to you soon.